Today we're going to go over solving quadratic equation by square root property. The other chapter, very beginning of the semester, we learned how to solve quadratic equation by factoring. So we're going to do the review of that in example 1. And then example 2, we're going to show you that we have another way of doing it, which is called factoring by the square root property. In order to understand that, first we wanted to make sure we understand that what's the standard form of quadratic equations, right? Where you put highest exponent into the lowest exponent. So x squared, x, and c equals to 0. One side equals to 0. We call this a standard form of quadratic equations. So one side is descending order equals to 0, where a have to be non-zero. So you have to have x squared on your equations. We call that standard form of quadratic equations. When we're using factoring to solve, we use the zero factor property, where if you have two value multiplied to become equals to 0, then 1 is equals to 0 or both equals to 0, right? So zero factor property, we use them when we're using solving by factoring. And the second method we're going to go over on example 2, square root property is using x squared is equals to k, then x is equals to plus minus square root of k, which means if you have x squared and trying to solve for x, we should be able to get rid of square by square roots. From previous chapter, we learned that square and square roots, they are inverse to each other, where they be able to cancel out when use them together, right? So that's how you are square root both sides of equations to get rid of square to isolate x. That's going to give you on the other side plus minus square root of k. Okay, so we will come back to that. If you remember, if you have equations look like this, and using, if we wanted to solve this by factoring, we need to recognize that this is going to be difference of square. So when you factor x squared minus 9, whenever you have two terms, you either use the greatest common factor or difference of square, right? And this one works difference of square, and it will give you x minus 3 and x plus 3. Once is factor form equals to 0, then let both factor equals to 0. That gives you x equals to positive 3 and x equals to negative 3 for two solutions. What about the next term? What about if you have 3x squared minus 5x equals to 28? Well, I realize this is three terms where I can make a standard form of quadratic equation first by subtracting 28 from the both side and equals to 0. So once you rewrite this problem into standard form equals to 0, then you can factor this. Three term, you can either find greatest common factor or factoring by trinomial. This one you can factor by trinomial, where you're going to get 3x plus 7 times x minus 4. And again, once you let both factor equals to 0, then solve for each x. So you subtract 7 and then divide by 3. This gives you negative 7 over 3, and the other x you get positive 4. So here is 2 solutions for that quadratic equations. The next one, until I simplify, we're not sure what types of equation this is. So how do we simplify it? Well, get rid of the parentheses. So if I wanted to get rid of the parentheses, I need to FOIL this, which I will get x squared minus 6x plus 9. And then you need to make one side equals to 0 before you factor. So you're going to subtract 16 and make it standard form. By combining the like term, you get negative 7. Once is the standard form equals to 0 and 3 terms. So we're going to do factoring by trinomial, and you get x minus 7 and x plus 1. This will give you positive 7 with negative 1. Okay, this time if we wanted to solve quadratic equation by square root property. Example A, we have x squared equals 16. So we need to remember, in order to use the square root property, one side have to be only square first. So if we're looking at this first problem, this left side have to be only value with square. If I have anything else, then I need to start by isolating term with only square. For example, the next one, I have x squared minus 8. So first thing I need to do is get rid of negative 8 because negative 8 is not square, right? So you wanted to start your problem by isolating term with square only one side and move everything else to other side. It means when we're looking at this problem, only this x is with square, plus 5 and times 3 is not, so you need to get rid of 5 and times 3 before you square roots. So make sure you're going to isolate the term with square on one side first. Once you do that, then you square root both sides, and when you're doing this square root property, you need to make sure put plus minus sign on the other side of equations. So square roots and square cancel out, where on the left side you will only have x remaining. The other side you will have plus minus square root of 16. And we know that square root of 16 is equals to 4. So your solution is going to be positive 4 and negative 4. And you can even check this to conform it. So let's check with the negative 4 first. So if you do x squared equals to 16, when you replace negative 4 to x, we know that's going to give you 16. Even if we replace x with 4, positive 4, we know that's going to give you positive 16. So negative 4, positive 4 all works out for these solutions. What about the next one? Remember, first thing you wanted to do is isolate the term with square on one side. So you're going to start this problem by adding 8 to the both side. Then you will get x squared equal 8. Now you can square root to get rid of square. If you square root one side, you need to square root on the other side and put plus minus sign. Then you get x equal plus minus square root of 8. And your radical solution should be the simplest form, which square root of 8 is 2 square root of 2. So here is another 2 solution for that problem. When we're looking at C, we do the same thing. We need to remember we need to isolate x squared on one side and move everything else to the other side, right? So first we subtract 5, then you get 3x squared equals to 6, and then you divide both sides by 3, you get x squared equal to. Once you have x squared on one side, then you can use square root property to get rid of square. Then you get x equal plus minus square root of 2. And we do understand we're going to get 2 solutions for quadratic equations, right? And quadratic equation, we do not have any restrictions, so you don't really need to check your solution unless you just wanted to make sure you have the right solutions, right? Let's look at the same types of problem, but it looks different because you're starting with the parentheses. So let's see, x minus 3 squared equals to 16. Remember I said that you wanted to start with one side with square terms only. And when we're looking at this problem, even though you have 2 terms, inside of the parenthesis is squared. So on the left side, you have square, only the square isolated. So you don't have to move negative 3 because everything is square. So long as you have a square one side, you can use the square root property. That will get rid of square. So you get x minus 3 one side. And then you have plus minus square root of 16, which is 4. And then in order to solve x, isolate x by adding 3. Then you will get, when 4 is positive, you get 7. When 4 is negative, negative 4 plus 3, so will be negative 1. There is 2 solutions. If you wanted to check if you got the right solutions, it's not must, but then you can check it out to make sure you have the right solution by replacing into the beginning of the problems. So when you replace 7, you get 7 minus 3 square should be 16. So that's 4 square. And we know that's equals to 16. What about if it's negative 1? You get negative 1 minus 3 square should be 16. That's negative 4 square is 16. So both solutions checked out. So then if we're looking at the next problem, first thing I need to do is isolate one side by square root. And this is the square root term. A square term, right? It means I need to get rid of negative 6 by adding 6, right? So then you get x minus 1 square equals to 6. Because you will have one side with square only, I can use square root to get rid of that square. And you need to put plus minus sign. Then you get x minus 1 equal plus minus square root of 6. And when you isolate x by adding 1, you get 1 plus minus square root of 6. This one, I don't really need to write it long, by adding, subtracting square roots, because this is going to give me decimal values. So you can just put 1 plus minus square root of 6. Where the other one, I had to go all the way because I know this is not going to be decimal and my solution have to be a simplest form. The last problem, exactly same thing. It's just that what happens if one of your value is fractions, right? So first thing I'm going to check is that I have this one side with only square. So then I can use the square root property. Then I will have 1/3 m plus 4 remains. And I have plus minus square root of 27. 27, we know that's 3 cubed. So it will be 2 out and 1 stay. And we isolate m by first subtracting 4. And then how do we get rid of 1/3 that is multiplied? Well, we multiply by 3/1, right? So then we multiply the other side by 3/1. That way that I will have only m remains on the left side. And when you multiply 3, you're going to get, so you basically have this 3 times negative 4 plus minus 3 square root 3. You're multiplying on the right side by 3, left side by 3. So since you had 2 terms on the right side, this is what you have. Or if you wanted to simplify your solution by distributing or opening the parenthesis, you're going to get negative 12 plus minus 3 times 3 is 9, square root of 3 will be your solutions.